So let's get started with part B of this assignment, visualization of crystal structures. So in this part, we were given a CIF file of PATIO3 and we were supposed to make changes in it and like obtain different crystals. So yeah, first I will discuss like how did I like do this part and then different crystals I made. So first I opened the CIF file of PATIO3 in Vesta software. I then went to edit menu, then edit data and unit cell. This opened a dialog box and I then selected the crystal system of the crystal, the CI file of the crystal I was making, and then the space group and the lattice parameter here. Then you go to structure parameters and choose different atoms in the unit cell, like potassium, oxygen or whatever, and then you choose this fractional coordinates here. Then you apply changes and you get your desired crystal structure. You can also choose ball stick, space filling or different styles like to visualize the crystals. So that is one thing. And let's see different crystals. So first is calcium telluride. So calcium telluride has a rock salt structure. So the calcium cations, they make up the FCC of the lattice, and the telluride anions, they occupy all the octahedral voids along different edges and the body center. So the effective number of atoms of both of them is 4 each, and the space group is Fm3 bar m. So I can demonstrate the point group like M3 bar m associated with this crystal. So if we see the 10 along the 100 plane, so we can clearly see there is a mirror which can we can clearly imagine a plane cutting through the screen along this line, and we can visualize the symmetry along this plane. So that makes it gives it M, and then along the body diagonal there is a threefold inversion axis. So as we can see from this figure, and along 100 plane, along here this plane, if we view the crystal, so again we can imagine a mirror plane cutting this unit cell into two symmetric parts. So so that gives it Fm3 bar m point group, and which gives it the space group of Fm3 bar m. Next up is gallium phosphide. So gallium phosphide has a zinc blend structure. So the gallium cations they make up the FCC, and the phosphide anions occupy the alternate tetrahedral voids. So the effective number of atoms comes out to be 4 each, and the space group here is F4 bar 3m. Now how did I come up with this? If you observe along this axis, we can see that there is a fourfold inversion symmetry here, and along body diagonal there is a threefold axis of symmetry. And if we see it from along this plane, 110 plane, we can imagine a mirror cutting this plane into two symmetric halves. So so this gives it the point group of 4 bar 3m, which gives it the space group of F4 bar 3m. Next up is potassium oxide, K2O, and it has the antifluoride structure. So the O-2 anions make up the FCC of the lattice, and the potassium cations they occupy the all the tetrahedral voids of the crystal. So the effective number of atoms this time, there are 8 effective number of potassium cations and 4 O-2 anions, which also gives it the formula K2O, because there are double the number of potassium ions. So and the space group here is M3 bar m, so same as calcium telluride. Now I don't have images this time because the size was a bit the size difference too big, so it be much harder to visualize. So but it is pretty easy to visualize that it has this space group. So Next step is cerium oxide, CEO2. It has the fluoride crystal structure. So it is like anti-fluoride only, but this time the cerium cations make up the FCC, and the O minus 2 ions occupy the tetrahedral voids. So this time the effective number of atoms is 4 and 8 instead of 8 and 4, and the space group is same as FM3 bar M. And yeah, this was cerium oxide. Next up we have gold zinc, AuZn. So yeah, so it is like a simple cubic CSCl like cesium chloride like structure. So yeah, you have like gold gold atoms making up the primitive cubic unit cell, and the zinc atom occupy the body center void. Like, so yeah, the effective number of atoms in one for both of them. And yeah, so the space group is PM3 bar M. Like, again, point group is same as the calcium chloride. So yeah, pretty easy to visualize. And yeah, that was part B.